Bernoulli's Differential Equation, Engineering Mathematics.
Hello future engineers and my dear students, welcome back to Mudassir Academy. I am Mudassir Sheikh. Today we are going to start with a very important topic, that is Bernoulli's differential equation. See, if you refer the past year VTU question papers, you will 100% find a question on Bernoulli's for 6 to 7 marks. So please take it seriously, watch the video till the end, don't skip any part and practice along with me so that you get the concept thoroughly and score full marks in the examination. See, in the previous video, we learned about linear differential equations. And I already mentioned that Bernoulli's differential equation is nothing but a type of equation reducible to linear form. That means the knowledge of linear differential equation is necessary. So, if you haven't watched the video yet, then please recommend to find a link in the description down below. Check it out for a clearer understanding. So, let's discuss the theory of Bernoulli's differential equation. So, before going to Bernoulli's, let's have a quick recap of the linear. See, we had discussed that the equation of the type, say, dy by dx plus py, that is, say, dy by dx plus py is equal to q, okay, where both p and q are functions of x. Okay, I'll write it here. Here both p and q are functions of x, is called as linear in what? Y, because see, there is y and y here. So we call it linear in y. And for such a linear form, the solution is given as y into e raised to integration of p dx is equal to whole integration of q into e raised to integration of p dx of dx plus c. This is the solution we discussed. Okay, now let me write this once again now. Say right here, dy by dx, I write this equation now, plus py equals to q. What I'll do? Simply I'll multiply it by y raised to n. Now if you see, such equation is non-linear. Getting it? This is what? Non-linear. So we need to reduce it to linear form. Equation as such is called as what? We call it Bernoulli's differential equation. We call this as Bernoulli's differential equation. Getting it? So this is called as Bernoulli's differential equation. Now I have dy by dx plus py is equal to q into y raised to n. So see this, only difference is y raised to n. So I have to make it linear. So first I need to remove this y raised to n. So the first step what we do is, we divide the whole equation by what? Y raised to n. Getting it? So what I do first? We divide by y raised to n. So let's see what happens here. When you divide by y raised to n, so 1 by y raised to n dy by dx plus y by y raised to n into p is equal to q. Okay, so that implies, I write it here. So we have as 1 by y raised to n dy by dx, and this will become plus 1 by y raised to n minus 1. Getting it? So y raised to n minus 1 into p is equal to q. Okay. Now we need to make this as exact using some smart substitution methods. Get it? Okay. So how do we do it? See, there is a simple trick here, understand it here. In a Bernoulli differential equation, always, this part, this part is differentiation of this. Getting it? See here. So I have it till here, agreed. Now see what I told, simple trick to understand. This part is differentiation of this. That means by using the very smart substitution, what I'll do is I'll put 1 by y raised to n minus 1 is equal to t. Correct? Or that implies y raised to 1 minus n is equal to t. Getting it? So if I take it, 1 by y raised to n, so the y raised to 1 minus n, that goes down. Okay. So now differentiate. So we have, it again implies 1 minus n into y raised to 1 minus n minus 1 into dy by dx equals dt by dx. That is implies again 1 minus n into, see, 1 cancels, y raised to minus n can be written as 1 by y raised to n dy by dx is equal to dt by dx. See what's happening here. So I can see 1 minus n, I taken this much. See, I have here 1 by 1. So it means I can find the value of this whole thing and substitute in terms of t. That means I can write here, that implies 1 by y raised to n dy by dx equals, if this goes down, we have 1 by 1 minus n dt by dx. Now what I told you, this whole thing, I will, in this place of 1 by y raised to n dy by dx, I put 1 by 1 minus n dt by dx. Getting it? See now what happens. That implies now, okay, if you put it in here, in place of 1 by y raised to n, I will substitute in terms of t. You have this, I will write 1 by 1 minus n dt by dx plus, what is, I have taken 1 by y raised to n minus 1 t. T into p is equal to q. Now what I simply do, I'll multiply. I don't need this 1 minus n because I want to reduce it to linear form. Let's see how it becomes linear. So that implies multiply by 1 minus n. So we have dt by dx plus 1 minus n into p into t is equal to q into 1 minus n. Now if you see what happens, this whole thing, see here, if you see it carefully, dy by dx plus py, y is equal to q. It was linear in y. So this also, if you see, dt by dx, t and t here. Okay, t and q are the functions of x here. This is what? Again, linear in t. In place of y, there is what? T, linear in t. So it is reduced to linear form now. So right here, so this is what? Linear in t. Therefore, the solution becomes nothing but t into, here it was y into, so we take t into e raised to integration of p dx is equal to, same step, whole integration of q into e raised to, again, what is that? Integration of p dx of dx plus c. So find the value of e raised to integration of p dx. Then what we do? We put it along here, find the whole integration, and last in the solution, you put t is equal to what? 1 by y raised to n minus 1. That's it. This is how we reduce it to linear form. Okay. So this understanding is little bit tricky. If you understood, okay, well, or it's not that much required, because we need to solve the problems here. The same technique is used to solve the problems, but solving problem is much more easier than understanding this theory. That's all with the theory on Bernoulli differential equation. If you understood it, well and good. Otherwise, no issue. Don't take tension. It's anyway not required anyway, because the same concept we are using to solve the problems here. See, my aim is to make the things, the solution of problems super duper easy for you, and your aim is to understand it, practice along with me, and get good marks in the examination. So please, if you are new to this channel, then take a second to hit the subscribe button right now. It is going to give me more and more support to make such effective and powerful videos like this, even though I'm suffering from severe health conditions. Okay, so now let's move back to the problem here. We have solved dy by dx plus y by x is equal to y square x, a most frequently asked problem in the VTU exam. So how do you solve this now? See, I write down one more time here. Dy by dx plus y by x is equal to y square x. This looks like, say, dy by dx y, linear in y, but it's not, because function of x, there is again x term here, there is a y square here. As discussed in the theory, into y raised to n, y square upon y square, something which is apart from x, anything y is there, and that is non-linear, Bernoulli's. Okay, so according to the theory as we discussed, the first thing what we do is remove this out. We divide by y square. Okay, so we divide by y square here. What we get? 1 by y square dy by dx plus 1 by y into 1 by x, right? Y square by y is 1 by y equals x. Okay, now we need to make it linear, correct? So again, if you recall the theory, we use a very smart substitution to make it linear, and I show you the simple trick also. It is always this part is differentiation of which part? This part. Always remember it. That means what I can simply do is, see, recall, differentiation 1 by y is what? Minus 1 by y square. Because differentiation of a very important differentiation to remember in engineering is differentiation of, it looks simple but it's very effective. Differentiation of 1 by x is minus 1 by x square with respect to x. Here, differentiation of 1 by y is minus 1 by y square d into dy by dx with respect to x. Correct? So what we do? We do a substitution. We substitute equal to t and make it as linear in terms of t. Let's see the process, how we do it according to theory. So we put 1 by y is equal to t. That implies differentiation of 1 by y is minus 1 by y square dy by dx is equal to dt by dx. But I need here only 1 by y square dy by dx. So do step by step. It again implies 1 by y square dy by dx equals minus dt by dx. Beautiful. Now I substitute for in this equation 1 by y square dy by dx 1 by y into 1 by x. I substitute for 1 by y square dy by everything in terms of t. That is, I taken 1 by y is equal to t and 1 by y square dy by dx is equal to minus dt by dx. I substitute everything in terms of t here. Okay, it implies what is 1 by y square dy by dx? It's clearly here minus dt by dx. Minus dt by dx. 1 by y is t plus t into 1 by x as it is equals x. So let's arrange this now in a proper form. So I'll multiply the whole equation minus and see what we get linear in. Dt by dx plus I take minus 1 by x into t equals minus x. Now, this is what? Our equation which is linear in y is given as dy by dx plus py is equal to q. This equation is what? Dt by dx plus minus 1 into t is equal to minus x. This is what? It is absolutely linear in t. So this is what? Linear in t. So the solution for linear in y was y into e raised to integration p dx. Here, in place of y, we have t. That's the difference. So therefore, solution is t into e raised to. So I will. So here you see here, what is p is equal to? We have p is equal to minus 1 by x and q is equal to what? Minus x. I write down first. Okay, then the solution will be t into e raised to integration of p dx is equal to whole q into e raised to integration of p dx of dx plus c. So that is t into e raised to integration of what is p here? Minus 1 by x dx equals what is q? Minus x into again e raised to minus 1 by x dx of dx plus c. That's the solution. So what we do here? We will find the integration for this part separately, put it here and then integrate again the whole thing and get a solution. So we have e raised to integration of minus 1 by x dx will be e raised to minus integration of 1 by x is log x minus log x, and that is again written as, see, we have discussed such conversions in the previous example in exact reducible exact also, where I mentioned a formula e raised to log of x is equal to x. E raised to log of x is only x, but it is minus here. So for that again this is a property of logarithm. Log of a raised to k is k log a, or k log a is equal to log a raised to k. So I want log plane here. So minus 1, so minus log x is minus 1 log x. This will be e raised to log of x is to minus 1, and as discussed, e raised to log of x is x only. So e raised to log of x square is x square. E raised to log of x to minus 1 is x is to minus 1. That is 1 by x. That's so that implies t into 1 by x equals minus x into 1 by x dx plus c cancels. Okay, and that will be equal to now minus 1 minus of integration of dx plus c. So t into 1 by x equals integration of minus 1 dx is x. Integration of 1 dx is x. So minus outside. So minus x plus c. That implies the solution will be now, what is t? Everything we are substituting in form of t here. Now let's write back the answer in x. What is t? T is 1 by y. It implies solution is t is 1 by y. So 1 by xy equals minus x plus c. So it is what? Minus x plus c. A beautiful solution here. So that's it. That's the answer. So we had the equation is Bernoulli's. This was what? Bernoulli's. So we divide by y square, and by using substitution in terms of t, we reduce it to linear in t, found a solution, and we substitute back the value of what we had put 1 by y is equal to t in the solution. That's it. Simple. The next problem here is solve tan y divided by dx plus tan x equal to cos y into cos square x. This is obviously is a non-linear because there is a cos y term here apart from cos square x. Okay, that means I don't need this cos y term. The cos y terms make it of the Bernoulli's form. That is divided by dx plus py is equal to q into y raised to something extra y term. Okay, that is what? This is what? Bernoulli's. Now once it is Bernoulli's, let's divide by cos y and see how we can reduce it to the linear form. So I'll write it once more down here to the question. We have tan y into dy by dx plus tan x equals cos y into cos square x. Let's write each and every step. So divide by cos y. Okay, because the right side should be in terms of x, there should be no y. So I divide by cos y to remove that cos y terms. To make it linear. So we have, that implies tan y by cos y dy by dx plus this will be tan x by cos y equals cos square x. Fine. Now 1 by cos is simple trigonometry. 1 by cos is secant. Correct. 1 by cos is secant. Fine. So we can write this as secant y into tan y dy by dx plus 1 by cos is again secant y into tan x is equal to cos square x. Now, as I told you, always in reducible to linear with Bernoulli's, always this factor is differentiation of this factor. That means I can use a smart substitution here because differentiation of secant x is secant x tan x. Differentiation of secant y is also secant y tan y into dy by dx whatever. So I'll put secant y equals t, and we are differentiating here with respect to what? X. So differentiation of secant x is secant x tan x with respect to x. Secant y will be, that implies secant y tan y dy by dx equals dt by dx. That's it. So nice. So directly got it. Secant y dy by dx is dt by dx. Nice. So I will substitute this whole thing in form of t now. Okay. So let's write down here. So let's write down the substitution. That implies, I write down here. That implies, what is secant y tan y dy by dx? dt by dx. I am substituting everything in terms of t. Secant y dy by dx is what? dt by dx. So dt by dx, secant y is what? T, plus t into tan x equals cos square x. So more standard form, I'll write it as dt whole divided by dx plus tan of x into t is equal to cos square x. And by looking at this equation, you can find that it is what? Linear in t. Linear in t. And for this linear in t, t equals tan x, t equals cos square x, right? Therefore, the solution will be t into e raised to integration of p dx equal whole q into integration of p dx of dx plus c. So that would be t into e raised to integration of tan x dx equals whole cos square x into e raised to integration of tan x dx of dx plus c. Now let's integrate this factor e raised to tan dx is tan dx, put it here, and again get a solution as usual. So we have e raised to integration of tan x dx. Recall some simple integration formulas you need to remember here, okay? So please do it. You may find it mostly in the formula sheet also, but better remember it. Integration of tan x is log secant x. What's that? Integration of tan x is log secant x. I repeat, lend your ears to me. Integration of tan x is log secant x. Okay. Again, integration of tan x is log secant x, and as discussed the property here, e raised to log of a factor something is 100. So same thing. E raised to log of x is x. So e raised to log of secant x is nothing but secant x. That's it. So put it here now. So we have t into secant x is equal to whole cos square x into secant x dx plus c. That is t into secant x is equal to integration of, again see, secant x is 1 by cos, correct? No, 1 by cos is secant x is 1 by cos. So it will be now, I write it here better because you don't get confused. Cos square x by secant x is 1 by cos into dx, okay, plus c, that is equal to, again cos and cos cancels. We have integration of cos x dx plus c. Such a simple integration. And integration of cos x is sin x. Integration of sin x is minus cos x. Integration of cos x is sin x. That is, I put it here in the form that implies the solution is, what is t here now? I have substitute t as what? Here secant y. Okay. T is substituted as secant y. So the final answer I write in terms of x and y. So t is secant y into secant x equals integration of cos x is sin x plus c. That's it. Beautiful solution. The question was the question was little some trigonometric terms difficult, but see the solution is so easy. Everything comes with practice. If you practice it, you'll definitely get it. That's it. Okay. So that's all for today's class. I have solved a couple of important exam questions here. I want you to practice more and more questions. Check the model question paper, check those question papers, and from that and solve it. Okay. If you're not getting the solution, please post in the comment below. I'll be solving them later. So practice well, solve plenty of problems, and be exam ready. All the best for your upcoming exams. Stay focused, study smart, and practice regularly. See you in the next video. Bye.